Hi, I'm Matt Needham, and this is my lecture on exhaust systems. When we think about exhaust systems, a lot of times you might think about a bathroom exhaust or something like that. Maybe a Bart Simpson might say a fart fan or whatever. There's going to be another Simpsons reference later in the lecture. Uh, Anyways, so you think of that, getting rid of foul air, air that you don't want, exhausting it outside, right? This has a little bit more of a commercial, this lecture, leaning than residential, but you can think of an exhaust fan in a bathroom, which we have in restaurants and buildings and all the restrooms and everything, to get rid of unwanted air for whatever contaminant or odor that we don't want. And it's not just necessarily bad smells or anything like that, or smoke. But a lot of times it could be like smoke or emissions or grease from cooking or dishwashers, all that steam. That's kind of what this is about. But also for industrial processes where you have dusts and things like that, there has to be some kind of regulations. Now, you can't completely exhaust everything and have a perfectly 0 parts per million work environment for everybody, but you can get it as as minimal as possible, and that's what it's trying to do here in the mechanical code with the regulations we're about to go over. First, to define a few things, the hood is like, if you think about, like, if you think about any restaurant where they do the cooking and then you have this big opening above where the air is sucked up and in, that opening where the air is first leaving is the hood. And then you have the ductwork, and a lot of times you might have a filter actually in there, particularly with a commercial cooking situation or dishwasher, some kind of mesh filter to catch particulates, grease, and those have to be taken out and cleaned periodically. You have the ductwork that then is going outside to take the contaminants outside, along with the motor and the fan to suck the air from inside, and then we're always trying to discharge that air outside the building, that bad air. And also, just another general concept I want to get going is every bit of air, every cubic foot of air that leaves a building is replaced, if it is leaving, is replaced with air that comes in. Otherwise, the exhaust fans would just suck all the air out of a building, we'd all suffocate, right? There would be no oxygen, right? So it has to be that way. That air a lot of times infiltrates in, is sucked in. And if you've ever been to a restaurant or something and you're having a struggle to open the door and the door is being sucked in, that's because probably the exhaust hoods are running, but the evaporative coolers, which bring in the makeup air to make up for the air that is leaving, may not be running. So you have this imbalance, you have this heavy negative pressure in the restaurant, and it's trying to suck air from wherever it can, and that's why you're struggling to open the door to get into a restaurant. And now you know. Okay, so those are some of the major components of the exhaust system, the hood. Sometimes we have, like, overcooking appliances, grease filters, these mesh filters that need to be cleaned periodically, the ductwork, the fans and the fan motors that drive those fans are all part of it. Okay, let's move on here. A lot of times, if there's a chance at all, we're designing these exhaust systems, particularly around things where there could be grease or whatever, or sparks, that the part of the motor, the electrical part of the motor, and also the bearings may not necessarily be in the air space. There's a lot of exhaust fans on roofs where you see this very, like, heavy duty shroud or casing over the motor and the fan, very heavy duty. You're like, wow, that's really heavy duty. I need to, get out a socket set to take this thing apart. And a lot of times that's because the only thing that sticks in the airstream is a shaft and a blower wheel, and the bearings and the motor is not in the airstream. This cuts down on the chances of fire because of the motor having electricity, and or the bearings, possibly if they went bad, there could be a spark or whatever, and we don't want if we're trying to get rid of grease fumes or whatever to start a fire. So that's the reason for that. Um, okay, let's move on. Exhaust ducts shall terminate outside the building and shall be equipped with backdraft dampers or motorized dampers that automatically shut when not in use. Okay, because we don't want there to be this opening all the time, especially where we can lose energy, where we're getting heat that's coming into the building, or we're losing heat or whatever out of the exhaust when we're not using the system. We don't want this air pattern to be there uncontrolled. Okay. Domestic ranges, like for people cooking at home, shall have a metal and smooth interior surface. Any hoods that we have, any ductwork that goes out, there can't be ridges where the grease can build up and then cause a fire. Similar for commercial. And then generally you don't always, especially in older homes, you don't always have a kitchen hood in a residence. In commercial restaurants and things like that, you will. Okay. Talking about clothes dryers, that's an exhaust. Okay. Clothes dryer is an unusual beast in that it's taking the moisture from your clothes and dumping it outside and mixing it as it's dumping it with the products of combustion of the fire that's heating up the dryer, and you're getting this warm, heavy, moist air with carbon dioxide, maybe a touch of carbon monoxide in it, coming off the products of combustion. And when you put those ducts together, because you have, like, particularly whenever you're putting exhaust ducts together, like for a clothes dryer, like when you do laundry, you're supposed to clean that lint trap every time, right? And if you have screws you have the exhaust duct that you hook up, if there's a screw like this on the inside, that can act as an anchor. It's incredible. And a giant tumor of lint over years can then occur and also block the flow, I had an issue when I moved into this house that I did my own home inspection, by the way, which went really well. But the one thing I didn't really notice or deal with was the house had been totally redone before I'd moved in. And the exhaust vent, the flapper, they had restuccoed the house, and you couldn't see it. It was on a 45-degree angle, but that little backdraft damper that I was talking about was sealed shut. So I did have a problem with that. Okay. All right. Let's move on. Okay. Also know this, again, like I said, whether it's a hood for a kitchen or a clothes dryer or whatever, if air is leaving, air is coming in from somewhere, right? And we have a tendency to get a negative air pressure, particularly in homes and restaurants and places like that, because sometimes someone has the bathroom exhaust on, kitchen hood, they're doing laundry, the dryer's on, right? And then maybe there's a hot water heater that happens to be maybe in an old kitchen or something in the house with a standing pilot, and then that negative air pressure can, when the burner comes on, can cause some flame rollout. So we don't want to have that, and we always want to kind of have a balance of air leaving and air coming in to our buildings, okay? And also, kind of going on along with ventilation, generally speaking, we try as much as possible to control the source of the air coming in with mechanical ventilation, or we open a window or whatever, because when it's just infiltrating in, you don't know whether it's coming in from a raised foundation, air under the house, which there could be some nasty things under there or whatever. It's finding its way in any which way it can. Whereas if you have a window with a screen, or you have an outside air intake or whatever, then we know the source of air and whether it's clean around that area or not. Okay. Let's move on here. 4 exhausts for like dryers again. Again, I'll just tell you this, that you have to have a minimum of a 4-inch exhaust. And then those first 6 feet can be an accordion type. So you can take the dryer, move it in and out, clean. It's a short run. It's not a smooth surface, but there's not like a lot of grease that can build up there, but lint that can build up there. And so you have that accordion, but you can then take that off. Also, you know, a service tip, I'll give it to you right now. Every once in a while, like, and I have such a long-term vision of certain things, like, you know, let's do maintenance every 10 years on this. Like, every 10 years, you know, what are you talking about? But sometimes that's the case. So when you take your exhaust off, and maybe every few years you should do this, off your dryer, you can take, now here is a lovely condenser cleaning brush that I bought at the 99-cent store for 99 cents. And it's used for like scraping off the dust from underneath your refrigerator condenser, which I highly recommend you do, and vacuum that. That's going to just, you know, there's a lot of brand new $2,000 refrigerators out there that are 6 or 7 years old that die just because nobody ever cleaned the condenser. Whereas if you just do that even every other year, it's going to last and last and last, okay? And also with your dryer, from the outside or the inside, however you can, if you take that accordion off, and you can bend this in there and get there in there and loosen up some of the dust and then suck it out with a wet dry vac, your dryer's going to operate better, save energy, less chance of a fire, etc. Okay? Also, I will tell you, I was remembering this, is because that exhaust duct was shut, I'll admit it. You're not supposed to do this, but I did it. I had to open, you know, as soon as we moved in, I had to take it off because the dryer wouldn't work. It was all stuccoed and gooed up on there. I ripped it off and I thought, well, I don't want vermin to go in there. So I stuffed a screen up in there, up inside, and I kind of forgot about it. And it built up with dust, and my dryer caught on fire. But I will tell you, having some skills, I don't care if you're the richest person in the world, I was proud that once we decided there was just a little bit of a meltdown inside the dryer on a Sunday night at 6, I had drove to Home Depot, found one on clearance outside, purchased it, and installed it completely, and we were drying clothes at 7:45 that same evening. So I don't even think Bill Gates could get it done that fast. All right, because you got to have skills. Okay. Now, but it was based on a mistake I made, so I can't be too proud about it. All right, here we go. 14 feet total. So again, from the dryer out, 14 feet total. 6 feet can be a flex type plastic or metal duct, and then we go a total of 14 feet, including 2 elbows. Okay, let's move on. All right, and all right, again, we have to bring in the adequate amount of makeup air if you have a big exhaust system. And then for more commercial type of exhaust system, you have to have a minimum velocity to entrain the stuff. If the air is just barely going out, the contaminants can fill up the ductwork. So here for things that just totally stay a vapor, vapors, gases, smokes, any feet per minute is acceptable. For fine, light dusts, you have to have a minimum of 2,500 feet per minute, so those dusts don't fill up the ductwork. For dry dusts and powders, 3,000 feet per minute. You've got to have at least that. You've got to have at least that flow, so the stuff can get outside or to a hopper or wherever you're disposing of it. Okay. Let's move on. A lot of talks here about a lot of these safety ideas. You know, in the United States of America, certainly with whether you think it was industrialists or robber barons, you know, it was just make a profit. We have disposable workers. If they die, just grab another one. And and a lot of the safety things were just figured out the hard way by deaths of people, really. And to such a point where then, you know, there'd be an uproar in the newspaper, and then codes were sort of created. But in 1800s, there's not really codes. And so it was like, you know, a canary in a coal mine. The canary in the coal mine. There's a police. Sting sings a song, "Canary in a Coal Mine," and from the police. And people used to take a canary in a coal mine because the coal, you know, when the fumes got so bad that people were going to suffocate because of lack of oxygen, the air so dirty, before people would drop dead in the early 1900s or even the 1800s, they would keep a little canary with them in a cage, and the canary would fall over and die right before the people would fall over and die, and that was their alarm system, that somebody every once in a while would look at the canary. If the canary fell over, like, okay, fellas, let's get out of here before we die. We've got, you know, 10 minutes to get out of here. So that was kind of, we learned the hard way to find out. And even now, still, we're learning different things. And one thing I did learn, I mean, I love the smell of a wood shop. And we teach carpentry where I teach at Trade Tech, and I like walking through the shop and smelling that and all the sawdust and everything. But try and guess in your mind for a moment, what type of cancer does being exposed to excessive amounts of sawdust over a period of years, what type of cancer does that cause in your body? Oh, wait. What do you think? It's nasal cancer. You're like, what? Cancer right up in here in your nose from breathing sawdust. Okay, so that's kind of weird. You wouldn't have you probably didn't guess that. And maybe I'll do a trivia question with that as part of the class. Okay. Okay. Let's move on. Central vacuuming systems within dwellings, they can use PVC. You're like, well, what is that? Well, let me explain. I think I've only seen one or two. People that live in mansions, they don't want the sound of a vacuum cleaner, no. They don't want any possible dust in the residence. So what they have, they don't even want to look at a full vacuum cleaner, no. What they have is, when the house is built, they have these plugs in these walls with a little flap, and then you have a vacuum hose, but that's it. And then you plug it into the wall, and you have a central system where the sound of the motor won't disturb the residences. And the maids and everybody can clean the house without any much of a loud noise vacuuming, because the motor, the vacuum, is in the garage or wherever in the equipment room, and it sucks all the dust there and then out. So those ducts, instead of having a vacuum cleaner, those can be made of PVC. So that whole show I just did that's all it was. Okay. All right. And ducts that are exposed to wide temperature fluctuations, that may be heating up for some industrial process to hundreds of degrees, they have to have expansion joints to allow for the expansion and the contraction of the metal. Okay. Let's move on. It says here, supports shall be of non-combustible materials, and spacing shall not exceed 12 feet for 8-inch ducts and 20 feet for larger ducts. So what we're talking about is when you're running ducts, and there's different regulations for different kinds of ducts, they're telling you you have to have a support that is holding the duct up every so many feet based on the kind of duct that you have. Okay? Just get that concept. And then there's a lot of sizing things that go on. Okay? Fire protection. If a duct conveys flammable vapors, okay, you actually have to have a fire sprinkler inside that duct. All right. Let's move on. Duct clearances. Ductwork and system components handling combustible materials and operating at less than 140 degrees shall have a clearance of not less than 18 inches from combustible construction or combustible material. Okay, so you've got to have clearances. A lot of times the code is a lot about how far should a clearance be from something hot or flammable, so that we don't have a chance of starting a fire. Okay. Let's move on. The chapter. Canopy size and location. For a canopy type commercial cooking hood, the inside edge thereof shall overhang or extend a horizontal distance of not less than 6 inches beyond the edge of the cooking surface on open sides, and the vertical distance between the lip of the hood and the cooking surface shall not exceed 4 feet. So actually just kind of pretend that this is a giant, the whiteboard is a giant cooking surface that you're looking down on from above. And the hood, which would be out here, it has to be at least like 6 inches here, overhanging, but it's going to be like out where you guys are, because you don't want the smoke to get out. You want it to be out, the hood to be bigger than the grill, so that all the smoke basically goes up. And then they're saying also that it shouldn't be, the opening shouldn't be more than 4 feet higher. This is just, both those regulations is saying that you have to have a really big canopy hood, bigger than the grill, to make sure all the smoke and vapor and grease fumes get in the hood. And then generally you'll see the hood, it kind of goes like this into a smaller duct or in through the grease filters and then out. But you have this big thing, so you get proper sequestration of all those fumes. Okay. All right. Let's move on. Let me get through this. Here on airflow, it says the air velocity through a duct shall not be less than 500 feet per minute and not exceed 2,500 feet per minute in general. So unless it's some special application, you have a regulation where you don't want it, if it's just like any kind of fume or whatever, you still need to have like 500 feet per minute just to make sure you have adequate flow going out. And then you don't want the ductwork to blow apart. And also, the faster the air, the more CFM going through the ductwork, the more noise and vibration you're going to have. Okay. Again, talking about makeup air, we can't be having a big negative air pressure in the buildings, particularly like in restaurants and things like that. Again, evaporative coolers are often used in conjunction with that, because they have water that drip down the sides if you're using the water function, the evaporative function, but they also have filters, and they bring in all this fresh air. And a lot of times they provide a little cooling for the kitchen, but they're providing that makeup air that you need so you don't have this big negative air pressure where you're actually sucking all the cool air from the air-conditioned dining room out into the kitchen, and then out through the exhaust hoods. Okay. And then, of course, we can't have electrical wiring inside of ducts for obvious reasons. Talking about fire extinguishers, sometimes when you have grease and things, you'll need to have a fire extinguishing system. Some points on that is with the fire extinguishing systems, even for any commercial building of any type, they have to go off automatically. It can't be where somebody's like, well, I think we're having a fire, I'll hit this big red button. No, it has to be automatic. But then a lot of times the reset needs to be manual, where somebody comes and goes, okay, it's safe to reopen the business, let me hit this button. Also, fire extinguishers being right there readily near kitchens. And how many of you actually have in your homes available a fire extinguisher? You should invest in one or two. I have a couple in my house, and then every once in a while I'll say to a family member, fire, where's the fire extinguisher? And they're like, I don't know. And it'd be like right in front of them. But yeah, I'm annoying to live with, no doubt. No doubt. My daughter died in a fire drill when she was 13. She just wouldn't get out of bed. I was burning I had a pot full of paper, and I lit a fire in it, and I filled the room with smoke, and she just wouldn't get out of bed. And I said, well, now you're dead and the fire drill's over. And yeah, you can see how annoying I would be to be your father. Okay. All right. Okay. Uh, all right, I just actually went over that. I went over the manual reset and the automatic sprinkler system, and then the importance of having portable fire extinguishers. Okay. Um, Now, the talk about inspection for grease buildup. The entire exhaust system shall be inspected for grease buildup by a trained, qualified, and certified person acceptable to the authority having jurisdictions in accordance with this following schedule. So, systems serving solid cooking fuel operations monthly. That would be like, a lot of times we'll have these nice rotisserie chickens. I like Peruvian chicken. They have these wood-fired uh, ovens that cook the chicken, and so those need to be inspected monthly. Or back east, they have, my daughter, different one is in Yale, and it's in New Haven, Connecticut, and there's two really famous pizza places, real famous, Frank Pepe's in New Haven, and Sally's Pizza. And they use coal, and they make these thin crust pizzas, great pizzas. I actually prefer Frank Pepe's, but everybody in my family likes Sally's. And there's even, you can look it up online. I told you another Simpsons reference was coming. There's a nice little part of The Simpsons where Mr. Burns, pretending he'd went to Yale, part of the Skull and Bones secret society, that Bushes were all part of. He's sitting in a room in Skull and Bones in a big cushy chair, and he's got like 5 phones next to him, all red, and it says, Washington, D.C., Beijing, Moscow, London, and then the 5th one is Sally's Pizza. The pizza's so good there that they abuse you if you hesitate. The managers, it's kind of fun. They're rude to you. Hurry up and order. What's wrong with you? It's kind of a unique experience, but I personally prefer Frank Pepe's. Again, these are solid burning. I said the coal. Now, the second reference to coal, the first one was the canary in a coal mine. Okay. It all comes full circle for me. It all comes full circle. Now, systems serving high-volume cooking operations like 24-hour cooking, charbroiling, or wok cooking quarterly. That reminds me of another story, real quick. When I first started in the trade, first, I got my first job during the summer when I was 18, and we were working on a roof, and there was this exhaust fan. I'll never forget this, on top of a Chinese restaurant, and there was a 10-foot diameter of solid grease, this thick, around the entire exhaust fan coating the roof. I never forgot that. Okay. So, obviously, their exhaust system had not been properly inspected or cleaned for quite some time, but again, this was back in the year 1984 of our Lord. Okay. Now, and then systems serving low volume cooking like a school or something like that, or a church or day camp, seasonal, just annually. All right, let's move on. Now here it talks about deep fat fryers shall be installed with not less than 16 inches of space between the fryer and surface flames for adjacent cooking equipment. So basically what they're saying is if you've got a deep fat fryer that can boil up, and you can't have another stove like right next to it, or oven or anything like that, because that grease can boil over and is heavy fumes, and you don't want that to start a fire. Now the fryer is designed underneath to deal with that safely, but maybe the open flame oven or range right next to it, somebody jammed up against it, could cause a huge fire. So you have to have at least 16 inches there between the two, which makes sense. Okay. And then the limit switch for those would be like 475 for deep fat fryer. Okay. Let's finish up here. Again, just having a maintenance log, it says you should have a maintenance log on site. Just having that filled out is going to help you a lot with inspections from building inspectors, health inspectors, etc. Also, although I think the EPA has lost a lot of its teeth now, the same thing is true with refrigerant records. Just showing a record of how you've used refrigerant and recovered it is important. And once, if they just happen to pop in, they ask you for that, then they'll go away. But if you don't have a record of what you used at your facility, now they start looking a lot deeper. Okay. Also, you want to have for wood burning, solid fuel burning operations, a spark arrestor. What is a spark arrestor? You know, regular fireplace, you know that screen that goes in front that you can close? That's the spark arrestor. Okay? And then a big spark can't come out, so you need to have that ready to go. Okay? And our last point here is it says here, make-up air systems serving solid fuel cooking operations shall be interlocked with the exhaust air system and powered where necessary to prevent the space from retaining a negative air pressure. So we can't just be running the exhaust fans and not the supply fans because we'll end up with a big negative air pressure. So that concludes my lecture on exhaust systems. Thank you.